Hi again. So today we will solve quadratics using our last method, and that's graphing. So in the end, you're going to have 4 different ways that you can solve a quadratic equation. You can solve by factoring, which I would do if you can, always, unless you're told otherwise. Then completing the square, the quadratic formula, and then today is graphing. So I want to start out with you looking at a problem that we've done before. So on a piece of paper, let's look at solving this problem by factoring. X squared plus 6x plus 8 equals 0. So I'm looking for a product of 8 and a sum of 6. And those numbers are 4 and 2. And so when I factor, I get x plus 4 and x plus 2. When I set each factor equal to 0, if x plus 4 equals 0, then x is negative 4. And if x plus 2 equals 0, then x is negative 2. Okay. That's what we've done before. Well, now I want to know, how do I solve the same equation, x squared plus 6x plus 8, but I want to solve it by graphing, so now it's set equal to y. So notice everything is the same. I have x squared plus 6x plus 8 equals 0, and y equals x squared plus 6x plus 8. So the only difference here is that we have replaced our 0 with y. So think about a graph. When we graph, y equals 0, replacing y with 0 or 0 with y, is the x-axis. You could label the x-axis as y equals 0 instead of x. All along your x-axis, your y values are 0. So technically what you do to solve by graphing is look for the places that that graph crosses the x-axis. So the x-intercepts are the solutions. Sometimes we call x-intercepts zeros because it's where y equals 0. And so we pay attention to that. Okay, so that's the real key idea, is that your x-intercepts are the answers when you're solving a quadratic by graphing. What we need to discuss now, though, is how do we get these graphs to a point where we can find those x-intercepts. And I need to tell you that much of this is done without a calculator. I expect you to know a lot of stuff about graphing parabolas. We just finished a whole unit on transformations. But also stuff before that, graphing parabolas without a calculator. So I'm going to review that first, and then we will talk about your calculator as a backup or as a part 2 for yuckier problems. So here we go. We have an equation, y equals x squared plus 6x plus 8. That's called standard form. This is what you used to see all the time when you graphed a parabola. You would look at it and you would say a is positive, so it's a happy parabola. You would look at it and say c is 8, so that's the y-intercept. And we knew that x equals negative b over 2a gave us the axis of symmetry. So you could find the axis of symmetry of this parabola by plugging into that. X equals negative b over 2 times a, x equals negative 3. Be careful to always write your axis of symmetry as an equation. It is a vertical line, so you must include the x equals. So if I want to start trying to graph this thing, I know some stuff now. I know that x equals negative 3 is my axis of symmetry. So my parabola has to be symmetrical around that vertical line. I know that 8 is the y-intercept, right about there. That's kind of all I know right now. Well, what you used to do is put your axis of symmetry in the middle of a table and substitute. So I have x squared plus 6x plus 8. So those are my x values, and we want to find some y values. Okay, well, when x is negative 5 squared is 25. 6 times negative 5 is negative 30, and then add 8 at the end. 25 minus 30 is negative 5, plus 8 is 3. So I can plot the point negative 5, 3. When I connect those points, I get my parabola. And since we're solving by graphing, we can say, oh, there are my solutions, the x-intercepts. X is negative 4, and x is negative 2, which is exactly what we got when we solved by factoring. So if you're given a choice, solve by factoring. You have 2 quick steps and you're done. But when you're told you have to solve by graphing, you need to know all of this stuff about graphing a parabola. And you look for the x-intercepts, where y is 0. Now, I also want to show you how to change the standard form of a parabola into vertex form, the form we've been using for that whole last chapter on transformations. And this is one of the big reasons we complete the square. It gets a parabola from standard form to vertex form. So I want to show you how to do that. Keep in mind, math is consistent. So we're going to go through the same 5 steps for completing the square, but we actually get to stop early because we're graphing, not solving. So step 1 for completing the square is to get your c term out of the way. So here I'm going to subtract 8. But instead of having a 0 to subtract it from, I have y minus 8. I subtracted 8 from it. Equals x squared plus 6x. I'm going to make a b list. B is 6. Half of b is 3. Half of b squared is 9. Add half b squared to both sides. So I have y minus 8 plus 9 equals x squared plus 6x plus 9. I can clean up this left side. Negative 8 plus 9 is plus 1. This side is now a perfect square, and you put half b inside. So this is x plus 3. Now is where you kind of make the break from solving by completing the square to graph. You have to keep in mind that we're graphing. I have a y. So when we graph, we want y alone. So your very last step here then is to subtract 1 from both sides. So y equals x plus 3 all squared minus 1. And when you look at this, this is now what we call vertex form, because I'm in that a times x minus h all squared plus k form. Our transformations form is vertex form. It's one of the reasons we do those transformations before we talk specifically about quadratics all the time. So now you should be able to look at this equation and say, oh, it's a parabola. It's moved left 3 and down 1, so its vertex is negative 3, negative 1. There that is. And from that vertex, it hasn't been dilated, so you'd go over 1 up 1 on either side, over 2 up 4, because 2 squared is 4. You could go over 3 up 9, and that would check and get you your y-intercept that's appropriate as well. Okay, so to summarize, to solve a quadratic by graphing, you need to know that the x-intercepts are zeros, and you need to be able to look at standard form and get key stuff out, how it opens, what its y-intercept is, what the axis of symmetry is. You need to be able to go from standard form to vertex form and get your transformations in so that you can graph it well and see your x-intercepts, which are your solutions. That's it for that part. I'll make a second video on using your Inspire to graph and solve by graphing.